going to be turning off my camera after a little while because I'm on limited internet bandwidth. So uh, yeah. Let me share my screen and get started. Uh, uh, sure. Yeah, Anuj, please confirm if this thing is visible.
Yeah. We can see you and we can see the screen as well.
Okay, I'm going to turn off my camera then and get started. All right, folks, let's get to it now. Uh, Vertex AI is a service offered by Google Cloud Platform, and I wanted to sort of raise this disclaimer before I even begin to talk about what Vertex AI is and different challenges faced when you are into machine learning systems. So I'm not going to be pitching the Vertex AI product to you folks. The talk is mostly about my experiences uh, that I have gathered from interacting with the product for some time now, and I thought that maybe if I shared these experiences with you folks, that might be helpful in order to ease some of the machine learning deployment related pain points. So that's really about it. I'm not going to pitch this product to you, and I'm not any advocate for Google Cloud or Google in that matter. So yeah, I just wanted to get that straight. Uh, okay, let's see. Now, sort of unapologetically reintroducing myself. So, I'm a machine learning engineer at Carted, and I'm an ardent open source enthusiast. I am actively contributing to TensorFlow Hub, Keras examples, and neural structured learning. So, of the work, I like to binge watch stuff on Netflix, and all of my coordinates are here at sayak.dev. That's sayak.dev. So, Uh, first and foremost, I wanted to acknowledge these people: Sarah Robinson from Google, Carl Weinmeister from Google, and Chan Sung Park. He is also one of the fellow MLGDs who has also helped me in preparing some of the content for this deck. So, and in case if you were wondering, this deck will be shared with you folks so that you can refer to it if it's needed. And question wise, feel free to stop me at any point in time and ask questions. But if I am unable to accommodate all of your questions, feel free to reach out to me via email. I'll share my email ID and stuff so that we can clarify things if needed. So this is going to be the brief agenda. I would really like to keep it interactive. That's why the agenda is not overtly elongated. So I'm going to be beginning by introducing some challenges that we face in MLOps today, rather the burgeoning domain of MLOps, and what it's meant when we say something like tooling for MLOps. I'm going to be shedding some light on that. And then we'll get to the Vertex AI part where I'm going to be walking you through some of the code snippets and some of the real world user scenarios that might be helpful for your own projects irrespective of the domain that you are working on. As long as things are well bounded inside the ML domain, I think it should be pretty extensible. And then we'll open it up for the formal QA. So yeah. So I'd like to begin by asking you folks some questions. So feel free to take part and yeah, answer. So first question is, do you train ML models continuously on new data? And I'd like some yes, no, or feel free to unmute yourself and just speak.
Yes.
Okay, that's one. That's good. And I'm sort of
No, we don't train continuously on new data.
okay.
We have new data continuously. It is coming, but we are not actually using it.
Okay.
Means continuous model development. It is not happening right now. But we have a plan for that.
Okay. I definitely think this session is going to be helpful.
Yeah.
Yeah, I'll take one more answer if anyone's interested, and then we'll proceed because I have got a lot of questions to ask. So yeah. So yeah, let's get to the second point. Uh, Do you deploy ML models continuously, or is it like a stagnant pain point that you are currently facing?
Yeah, as mentioned by Bishwajit, it's not continuous currently.
Okay.
It's like a stagnant model for us. But yeah, that this is the plan for future. Yeah.
Okay. So if I
Basically, to do it.
understand this correctly, uh, you are currently dealing with all of this in a sort of very manual fashion, right?
Yeah, yeah.
That's why
It's
the continuous part is not getting incorporated, if I'm not wrong.
yeah, correct, correct. We're doing building the model locally, and then the model is getting transferred, and there it is stagnant. It's not changing.
So there are sort of manual handoffs in between these processes.
Yeah, yeah,
Yeah.
correct.
Okay. Then yeah, good, good. So do you deploy multiple kinds of models? So next question is that, and I'll really like if other folks also contributed to this little session.
Yes, we do.
Yes, yes.
Yeah, cool, cool. All the good stuff. Uh, are you training? Uh, so are you treating model? That's a typo there. Are you treating model training and deployment as a CI/CD system?
Yes.
That's great. That's really great. What about other folks? Is
Yes,
CI/CD yet to be incorporated?
yes, we are already doing it.
Great stuff. Great,
Mm.
great. So may I sort of know the kind of technical debt or the tooling that gets arised when you try to treat training and deployment as a CI/CD system? What's the technical debt? Like to what extent the debt arises? Okay, maybe we can get to that later after I present a couple of case studies. But yeah,
I also
uh,
do Apache Airflow.
sorry.
Airflow also for the
No, no.
pipelining and all.
So my
Yeah.
question was, how much of a technical debt uh, does that process introduce? Apache Airflow is all well
Yeah.
and good, but I was more concerned about the
Not much. I
technical
do
debt.
not much.
Okay, not much. Cool. That's good to know. So my next question is: do you perform model monitoring at frequent intervals? Because we were talking about new data, and it's also important
Ye-
to monitor your model quality. Are you doing that?
Yes, yes, yes. That happens whenever new data comes. We test our old model whether that is working. If not, then we add the new data and rebuild the model.
Okay, so you do things like skew and drift detection, and then based on some predefined threshold and North Star metric,
Yes,
you do the
yes,
stuff.
yes, yes,
Cool,
yes, yes.
cool, cool. The next, probably the pre-final question is: are your models equipped with auto scaling? I mean, if let's say rather than serving 10,000 requests at any given point in time, if it were to scale to billions and billions of requests, are your models well equipped with auto scaling?
For us, in our project, it is not. I mean, the requirement is not in that way. So yeah, of course, it's not equipped in that way. But I, I'm not sure about others.
So
Even for is auto scaling is not required because we are not dealing in a real time right now.
okay, okay, makes sense. But rather, you would prefer if you had the option to set up auto scaling with 2 or 3 lines of code without introducing lakhs of costs. Will that
Yeah, yeah,
be
Yeah,
suitable?
that will be great. Yes.
Oh,
yeah,
yeah,
yeah.
cool,
Of course, that is a better
cool.
option. Yeah.
Yeah, so just to get that point right, even if we are not serving, let's say in real time, even if we were doing things in a batched manner, still there can be a possibility that instead of like making batch prediction on thousands of records, it can get to millions and millions, right? So in order to be able to cater to those scenarios, I think auto scaling is sort of compulsory. But yeah, anyway, I hope you got the point. So this
Yeah.
is the final question. Are you managing all the artifacts produced at each of the steps involved in your machine learning project? Because data processing produces some artifacts, model deployment produces some artifacts, feature pre-processing produces some artifacts. So are you managing all these artifacts in a sort of efficient manner?
We have started to use DVC to
Okay.
fulfill that purpose.
Okay, so if at any point in time I wanted to have all the metadata related information for a given step in a pandas data frame, let's say, I should be able to do that without thousands lines of code, right? I mean, I would rather have that system. I mean, that system would be great, right?
Yes, yes, but currently it's not done in this way.
Okay, cool.
GitHub
Uh,
plus DVC, we can actually do that.
yeah. I mean, of course, you can develop your own tooling around that. You can use DVC and GitHub and use all their, offered APIs in order to be able to query things at scale. But yeah, I got your point. That's good to know. And with this, I'll leave the questions at their own places and we'll get started because I wanted to sort of have an understanding where folks are and whether or not this session is going to be useful in the first place. So yeah, I hope this is going to be useful. So yeah, so let's cut right to the chase. For some context, I'd like to introduce what MLOps is. So as per Google Cloud, an ML engineering culture and practice that aims at unifying ML system development, which is development, and ML system operation. So MLOps is more like a sister to what we call DevOps in traditional software engineering. Now, some of you folks might be wondering why are we treating MLOps as a different thing from DevOps, right? And I'd like to answer that question first. So because it's kind of hard stuff, and in machine learning, randomness, stochasticity, uncertainty, these things can get introduced in all sorts of different ways, right? And as you can see in this very popular figure, the amount of machine learning code in any machine learning system, let's say, is very limited and it's very less compared to all the other proportions. And it's probably not what one would think when they are starting their machine learning journey. But yeah, as you can see, the amount of ML code needed in order to bootstrap any machine learning project is literally this amount. So, but I mentioned it's hard stuff because with that machine learning code, you need to incorporate all sorts of things, right? Monitoring, data verification. You need to have a separate serving infrastructure, a separate pipeline for feature extraction. Then comes the problem of machine resource management because in order to train and serve machine learning models at scale, you need different capabilities, and definitely resource management without introducing too much costs is definitely one of those requirements. So with just having that machine learning code to state of the art is not done. You need to have resilient, reliable, and safe systems that can actually accompany your machine learning code, so that you can reliably operate with your machine learning systems. So but it's important stuff too. MLOps practices can actually help you productionize and standardize ML systems rapidly and reliably. And I mention rapidly because a machine learning model can get old within days or within seconds. Let's say, let's consider the upper bound here. Let's consider the worst case scenario here. It can get old within a fraction of minutes, if not hours, right? If you are especially operating with time series data. That's why I mentioned rapidly that. So in order to be able to account for those drifts in your new data, you need to rapidly train things and be able to deploy it and then sort of iterate on that process and reliably, because you wouldn't want to have your model go crazy on uncertain data points. You would like a system that would report that uncertainty in a sort of efficient and reliable manner, and so that you can actually take some actions on it and improve it over time. So that's why I mentioned rapidly and reliably. Okay, so I'd like to also give give an inside look as to how machine learning ML ops is typically practiced these days. So we we typically have separate teams. I mean, uh, at the worst case scenario, we have two teams at the very least. One would be on the data science side, and one would be on the IT side, which would take care of all the deployment and scaling related stuff. So as we were discussing before, there are different hand-ups in between different processes, and these hand-ups are typically manual in their nature. So typically, data scientists and machine learning engineers will train their model, test it on some test bed, will also do some test bed deployments and canary rollouts, and then finally they will hand it off to the IT team so that they can sort of polish all the code written by machine learning engineers and data scientists and sort of take things from there. Excuse me if someone is not speaking, could you mute yourself? I hope that's not too much. Okay. Thank you. So yeah, these two teams are typically isolated and decoupled, but as you can probably understand, someone that is deploying a machine learning model needs to have some amount of machine learning knowledge, because even if the machine learning model is well tested during production, it can fail in all sorts of ways, right? So it's important to have that knowledge sort of pre-developed in order to be able to tackle those scenarios. So how do we do that? How do we actually not decouple these two teams and make them operate simultaneously? So MLOps can be very helpful. Modern MLOps practices can be helpful in unifying these two teams so that they are operating in tandem and constantly training and deploy things in a sort of CI/CD manner. And this is exactly one of the situations where modern MLOps practices can be really helpful. So as I was mentioning before, with machine learning projects, you have your own sort of challenges apart from the production related challenges. So on the right hand side, we have the common production related problems like scalability, affordability, portability, and so on. But with these things, machine learning specific related challenges also get introduced in the pipeline, right? So governance of data, because data is the first class citizen in any machine learning project. Then comes the requirement of continuous training and deployment, training serving skew. So because the data can get newer over time, and then comes requirements like model analysis, fairness, and explainability. So how do we sort of cater to these ML specific challenges in a sane manner without sweating too much of a sweat? So yeah, that is one of the main focuses of this session, and I hope I'll be able to deliver on that front. So yeah, so enter Vertex AI. Vertex AI is a pretty new product, and it was announced in this year's IO, but I have been using it for quite some time now, and that's why I wanted to sort of share some of my learnings and present you with some real world user scenarios that could be extended in your own projects. So Vertex AI is a managed ML platform for every practitioner to speed up the rate of experimentation and accelerate deployment of ML models. So as you can see, if you are currently operating from a Jupyter notebook for rapid experimentation and stuff, Vertex AI has got tooling for that. But if you are taking your models out of your notebooks and sort of incorporating all the MLOps related practices, Vertex AI has got tooling for that as well. So no matter where you are at in your MLOps journey, Vertex AI has got tooling for that. So as you folks probably are wondering, this guy is talking for a while now. It would be great if you could show some code. So yeah, here you go. So let's actually cater to the first scenario. Let's say you want to be able to train a model quickly on a subsampled data set, and you want to deploy it to gauge some North Star matrices and then sort of iterate from there. So here's how you can actually submit a custom training job for an for training an image classification model with Vertex AI's APIs. And here you can see the task.py, that's actually a Python script which containerizes everything that's related to your model training. And this includes, this can include hyperparameter tuning. This can include model training right off the bat using TensorFlow and Keras APIs like model.compile and model.fit. It can be any framework. It can be PyTorch, it can be MXNet, and so on. So you can also specify all your custom requirements. You can start with a base Docker image. That's what we are specifying here, train underscore image. And then we are also specifying an image to which will be used in order to serve the predictions in case you want to deploy your model. So that's literally 4 lines of code because I indented it. So, and then we are basically submitting that custom training job to Vertex AI so that it can run it in an asynchronous manner. So after submitting this job, we can go out and have a cup of coffee or do whatever we need to in order to relax ourselves. So that's it. And if your training needs more compute resources, that's also possible. And that's done by specifying replica counts, machine types, accelerator types, and accelerator count accordingly. So you can do all sorts of things like mixed precision training, distributed training by setting these hyperparameters accordingly, right? And let's say our model training is complete. Now we want to be able to use that model in order to do real-time predictions. And these are exactly the lines of code needed in order to deploy your model to Vertex AI, which can serve millions and millions of requests if you scale it up accordingly. So the first line is pretty much straightforward to read. It's the deployment name. You probably want to have multiple deployments, so that's why it makes sense to give your deployments unique names. And then we are basically specifying traffic splitting. Now let's say you have got 5 different models in your deployment, and these models are basically divided with respect to the regions they are catering to, right? And then you would want to be able to provide some traffic splitting mechanism so that these models can handle the prediction requests accordingly. Here we are dealing with a single model. That's why I have sort of provided the model ID and set the traffic splitting to 100%. But you can think of other ways, right? Let's say you want to be able to do canary rollouts and A/B testing, where you want to deploy your new model, but you don't want to, cater to all the prediction requests, but only a small fraction of those requests to better understand the new model behavior. So in those cases, traffic splitting can be really helpful. And then you can specify what should be the auto scaling limit, what should be the upper and lower bounds of that auto scaling. I was mentioning, are your models well equipped with auto scaling? Even if you are not considering auto scaling at this point, you can always set it up. I mean, it's ideal if you could set it up when you are deploying your models in the first place. And Vertex AI lets you do just that with 2 or 3 lines of code, as you can see. And with model.deploy, we are actually deploying this model that can be consumed using, REST API services or the CLIs, the command line interfaces provided by Vertex AI. So you can again configure all these things: traffic splitting, what machine type you want to use. If you want to serve your model using multiple GPUs, that's also possible. But if you want to do it using CPUs, that's totally possible. Now, this deployment is for online predictions, which means that this deployment is ideal when you want to consume your model in a real-time basis. But what about batch predictions? I remember someone was mentioning it's currently running offline, so we are using batch prediction. So, and again, so all of these things can be done using a Jupyter notebook. To be very specific, you can do all of these things using a Colab notebook. You won't need any, configurations and stuff like that. A Colab notebook will be provided to you. You can visit this link. As I mentioned, I'll provide the PPT, provide a link to the deck after my talk. So basically, you can run this Colab notebook without having to worry about all the configurations, but you can still get your model training done and deployment done just by, executing a few cells in that Colab notebook. And Colab notebooks are basically hosted Jupyter notebook that gives you free GPU access and CPU access for a very limited period of time, but it's entirely free. So yeah, but so coming to the point, what about batch prediction deployments? and that is also possible. So we just call model.batchPredict and submit, let's say, billions of records to our model, and then we let it run for a couple while, and then all of your sort of results will be written to a location that you will specify, and this location is typically Google Cloud Storage buckets. So yeah, your asynchronous training code remains the same, but just for running batch predictions, you need to incorporate 4 or 5 lines of code. Again, the API call is just model.batchPredict and nothing else. So it's highly customizable as well, but I'll leave you to a collab notebook that can walk you through all of that customization. But yeah. Now, before we move on, anyone has any questions on these points?
And train model already that we trained on some other device on our own GPU, say, and then we want to make prediction on that. Is it possible to do so?
Yeah, so you want to train your model on your custom
Suppose
premises, and then
already have that model.
yeah, so then you would want to deploy it on Vertex AI, right? That's your
Yeah.
question. Yeah, that's possible, but given a few restrictions. Yeah, these restrictions are your model should be in saved model format, and it should not be lesser than it should not have been trained in a version of TensorFlow less than 1.15.
Okay.
But other things are possible with a bit more involved code. But if your model is in other format, you can always create the custom Docker containers and have Vertex AI communicate to that. And the collab notebooks I have linked there actually walks you through that process. So yeah, long story cut short, it's possible. But right off the bat, if you want to take advantage of Vertex AI's APIs right off the bat, then those restrictions apply. So yeah.
Okay, thanks.
Yeah, cool. Anyone else? So I haven't yet introduced all the offerings of Vertex AI. These are just the training and deployment part. I hope these are the most favorite things of a machine learning engineer. That's why I wanted to get that big elephant out of the room. But yeah, happy to answer more questions as we proceed. So what's all included in Vertex AI? What is it only about training and deployment and nothing else? As machine learning is not just about training and deployment, right? So it provides you an entire stack of services that you need in order to succeed in your machine learning journeys, right? It starts from the data readiness part and takes you all the way up to model management, model monitoring, and stuff like that, and all the state of the things offered by Google in terms of model tuning, model training, model prediction, auto scaling, and stuff. All those things are included. So let's say you wanted to only have the tuner component from Vertex AI. Vertex AI has got APIs for that. And then in the other scenario, let's say you want to have model tuning as a part of your larger workflow. Let's say as a part of your some overall Kubeflow pipeline, that is also possible because pipeline helps you to orchestrate the different steps that might be included in your machine learning journey, right? That's also totally possible. So these things can be decoupled, but these things can be coupled in a sort of very neatly integrated manner. And Vertex AI also provides deep learning environments that you can readily use either if you are customizing your setups, but it also provides notebooks that are pre-configured with these deep learning environments to make it easier for you to get started right off the bat. So these are some of my favorite components from all the stack of services provided by Vertex, and this includes model training, continuous monitoring, and VZR optimization. I'll get to that in a moment, and pipeline orchestration. So Vertex AI has got a separate component for orchestrating and executing all of your pipelines, and currently it supports Kubeflow pipelines and TensorFlow extended pipelines. And by VZR optimization, I mean VZR is basically a system developed by Google, and it can pretty much, optimize any black box function of your choice. And these black box functions can include your machine learning model. This is basically a function, or can any mathematical function that you can evaluate. So that's the beauty of easier optimization. You don't need to have finer access to your model in order to be able to optimize its hyperparameters. So yeah, in a sense, having that black box optimization in your pipeline can be very helpful, because you don't need to bother about the internals of your model when you are tuning it. Of course, you should be bothering about that, but when you are tuning it, then you would like the tooling to take care of all the pain points and still provides you with enough room for customization. So Vizier optimization can actually do that for you, and it can run at scale. So if you wanted to tune your models that's being trained on billions and billions of records, that's absolutely possible. So with that, let's see how Vertex AI's offerings can fit in your application development lifecycle. So basically, you will have desktop clients, mobile clients, and other clients as well. But yeah, I have included the two that I personally operate with. So then you will have your application logic, and from your application, you will basically connect all the Vertex AI bits that are specific to your ML challenges, right? Because Vertex AI's offerings can be consumed using easily programmed REST APIs. It should be straightforward to be able to incorporate that from your application, and these APIs come in these API bindings rather come in different languages, and these include Python, these include Rust, these include C++, and so on. So I hope that language set covers the kind of stuff that you're operating with. And of course, it also includes Java in case Android folks were wondering. So Kotlin support is on its way, but still, I think the REST API binding support is pretty neat in that manner. But if none of those offerings suit your application stack, you can always consume their CLI, which should be again pretty straightforward. Okay, so now now my point is my model deployment is done at scale. We have basically incorporated all the bits that are related in order to auto scale my model. So basically, I'm done deploying my model. Now, maybe the team decides that we could go on a trip, maybe, but we haven't yet dealt with one of the most important factors that actually gets incorporated after you deploy your model. Now, after should be bold and italics, right? Because the bit that I'm about to discuss only comes after your model deployment is done. Now, the point is model monitoring, right? So now when back in the day when we were sort of starting in machine learning, deployment was the ultimate thing. But as it stands out in ML ops, a deployed model is only the beginning. You need to be able to keep track of all the concept drifts and other skews that your model might be meeting with after it's deployed. So how do we actually incorporate model monitoring after our models are deployed, and how do we orchestrate with that workflow in a reliable manner? So model monitoring is one of the challenges, and it's definitely not something that is provided right off the bat using the cloud services that we are using. Of course, sky's the limit. You are open to develop your own tooling, but won't it be nice to have some tooling support from the giants in the industry, right? So that's what Vertex AI will be offering. So Vertex AI has got a separate suite of APIs that you can use in order to monitor your models. And I would really like to have certain qualities if I'm consuming a service that is related to model monitoring, and this should include automatic alerts. I should be able to automatically alert the respective teams so that they can take actionable and immediate, so that they can take immediate actions, right? And these alerts should, of course, include actionable insights, and it should be able to quantify the drift that has happened over time, and also it should be able to quantify the training servings queue, right? Because we want to be able to set some threshold so that we are not getting some false alarms, right? And it should also, provide confidence in model reliability. So let's say you have 3 or 4 models, or let's say 5 models, and you, based on all the metrics reported by the model monitoring service, you want to be able to also quantify the confidence of each model and then take further actions from there. So, and as always, Vertex AI's model monitoring offerings can be incorporated in your workflow just from a collab notebook, and I have also provided a link for that. And the graphics are really beautiful. You can really zoom in on any point in your, model monitoring journey and exactly quantify, okay, this is the drift and this is how it has changed over time. So it will give you a sort of rolling average of all your, skew and drift changes. And now you might be asking, how do we do this in a sort of continuous manner, right? Okay, I have incorporated model monitoring. Then if I wanted to sort of make some changes in the data input pipeline, maybe some, some recent feature pre-processing logic and stuff like that, how do we go back there and do not break the code base, right? You should be able to do this in a sort of iterative and continuous manner. And how do we actually do that? So in order to be actually able to do that, you need pipelines in place that are iterative and continuous in nature. Because based on some model monitoring matrix, you want to be able to go back to any step within your pipeline and then again redo all the steps that are following that particular point. Now, if we wanted to sort of go back to the initial data input pipeline stage, that should be also possible, because pipelines are essentially graphs, and when things are represented in a graphical manner, it's easier to, visualize them and, sort of traverse different things that are included in that graph. So as I was mentioning, currently Vertex AI pipelines can seamlessly operate with Kubeflow pipelines and TensorFlow extended pipelines. So Vertex AI pipeline is basically is an orchestrator. If you are familiar with Cloud Composer, it's more of like a Cloud Composer thing, but sort of developed in a very machine learning specific way. And this pipeline should be sort of automated, scalable, serverless, because it should be fully managed, right? You should not set up, separate servers in order to, allocate resources for the different stages in your pipeline. And it should be cost effective. You should only pay what you are using. Like, the pipeline should not charge you for the steps that were not executed in the first place, right? That's where the cost efficiency comes into the picture. And let's say we wanted to add conditional logic to different branches in our pipeline. That should be easily supported. And by conditional logic or by conditional branches, I mean, let's say based on some predefined accuracy threshold, you want to only deploy that model that crossed some predefined accuracy threshold. Otherwise, you would want to, stop that deployment. So by conditional logic and branches, I mean essentially that it should be easily doable using Vertex AI pipelines. So and at each step of the pipeline, you should be able to keep track of all the artifacts and the metadata generated, right? And it's not about the authentication that is provided by Google by default. You should be able to set up your own authentication services along with this Vertex along with this pipeline. So that is also possible. And let's say you want to be able to keep track of all the lineage of the artifacts generated at each step of the pipeline. That is also possible. And you can sort of customize where your metadata is getting saved and how this should be interacted by your fellow team members. That is also possible. Okay, so that is like the bird's eye view of the pipelines offered by Vertex AI. Now let's actually see how does this look in code. Now I'm considering a very typical scenario of a pipeline. Let's say I want to first create a managed data set, and then I want to be able to train a model, and then I want to be able to deploy it so that it can be consumed by other teams in your project. It's a very common machine learning workflow. That's why we are doing it here. Now, this is how you would define your pipeline using Kubeflow pipelines, but TensorFlow Extended is also supported, as we will see in a moment. So in the first step, we are basically provisioning the dataset so that it's well managed. Then we are configuring our training job, and then we are writing our model deployment operation. So as you probably have noticed, this is an AutoML service provided right off the bat by Kubeflow pipelines and Vertex AI. So in some cases, AutoML is great, but in some cases you want to be able to customize your models to great extent, and that is also supported. If you are familiar with Kubeflow pipelines has got a separate component that can deal with your custom model training code. But if you are dealing with TensorFlow Extended, that is also supported. You should be able to write custom components that can interact with your custom model training components as well. So this is how you write the pipeline. As you can see, this is probably 10 to 15 lines of code. And here we are basically training a regression model. So yeah. And then you compile it, and then you submit it for execution to Vertex AI. So it's literally just that. Apart from the model import and installation steps, it's literally just that and nothing else. And I haven't really cut out any of the important code snippets from here. And you can verify this by yourself from the collab notebook that I have specified here. So as you can see, at each step of this pipeline, an artifact is getting generated, which is then sort of consumed by the subsequent steps involved in your pipeline. And this artifacts are, serialized in a central repository that you can configure. By default, this get stored in a central Google Cloud storage, but you can always configure that. So yeah, any questions? All right, let's put. Oh yeah, question. Someone was asking a question probably. Okay, let's proceed then. So what about more complicated logics? Like I was mentioning before, uh, what would happen if I wanted to, first evaluate a particular model that's been trained on the dataset on some holdout test data, and based on some predefined matrix threshold, I want to be able to deploy it. So if the trained model does not pass that predefined threshold, I should be able to stop that deployment and sort of go back to the first step and then redo the entire pipeline. So conditional branching is of course supported right off the bat using Kubeflow pipelines, and as you can see, the pipeline sort of depicts the mental idea for what you should be doing in order to cater for conditional branching. And what about the code? Of course, more code, but certainly doable from a collab notebook. And I keep emphasizing the collab notebook part is because you don't need to write separate modules and develop your own Python library in order to be able to do that. Using Vertex AI's offerings and using your own custom code, things should be pretty much doable from a collab notebook. Of course, when you are operating inside a team and when you are working at a company, probably you would want to maintain well written code and clean code and have some linting in place, automated linting in place. But in order to get things started, I think you can pretty much gauge the feasibility of a project from a collab notebook. That's why I keep emphasizing the collab notebook bit. So yeah. And standard KFP components that connect well with Vertex AI's offerings. These are some of those components. So AutoML image training job, these are again AutoML stuff, but you can always go for the custom training job run op, where you can specify your custom model training module, and then Kubeflow pipelines and Vertex AI will take care of you for that. So batch prediction is also supported, deployment operation is also supported, as we saw in this code. So yeah. So this is for the Qflow pipelines and Vertex AI's integrations, but it's also possible to use TensorFlow extended and have that orchestrated from Vertex AI. Now another scenario that probably you wanted to cater to is, what if I wanted to allow two different models? Now a classic scenario for this is, let's say you have a separate web client for your machine learning system and you have a separate mobile client for your machine learning system. Now for the web client, probably communicating with the cloud APIs is good, but for the mobile client you want to be able to have your model operate in an offline manner. That means even if there's no internet, your client should be able to consume your model. So how do we do that actually? And often, we have models hosted on cloud APIs that may not, translate well to mobile clients. Let's say I have deployed a ResNet 50 that I am consuming from cloud APIs, and ResNet 50s are not really well suited in case they were to run in an offline manner from a mobile device, because mobile devices have restrictions in terms of sizes and all sorts of other stuff. So in those cases, having mobile-friendly architectures like NASNet, MobileNet V3, and so on are more preferable, right? So how do we actually, train two different models and deploy them on two different platforms? Because I mentioned this because for mobile clients, you would want to use Firebase, because Firebase has got a very tight-knit support for dealing with TensorFlow's mobile-friendly framework called TensorFlow Lite, and you would want to be able to convert your trained model to TensorFlow Lite and rapidly deploy it to your mobile client. And Firebase can take care of a lot of things for you in those regards. And regarding the cloud-based model, let's say we want to be able to deploy it to Vertex AI's platforms and have all the prediction requests made from there. So this is a typical scenario, and I have personally worked in a project that used to have this scenario. And again, sky's the limit here, really. It's not just about two different models. If let's say we wanted to have n different models for n different platforms, it should be pretty much doable. So, and again, it's doable from a collab notebook. So yeah, as you can see in the pipeline, we are basically training two different models and deploying them to two different platforms. Now we can definitely horizontally scale this thing up to n different models and n different platforms, as I mentioned. So yeah, any questions?
Yes, in case of mobile deployment, what is the
Sorry.
output?
So for mobile deployment, what we are basically doing is we are first training the model, and then we are converting it to TensorFlow Lite, and then we are pushing that model to Firebase so that your mobile application client can consume that model from your Firebase storage. And for Firebase storage, it's just one line of code in order to consume your TF Lite model. Yeah.
Okay, so the training is also different. It's not just we are training some model, say ResNet 50, and then converting it to TF Lite. We
No,
are
no, no, no. The model architectures and their training pipelines are entirely different, but the data set is the same.
okay. Sorry, just one more question. Uh, I don't know much about Qflow. I haven't worked with it, but can we monitor our experiment somewhere using that? Do we have a
Yeah,
dashboard for
yeah. So
that?
if you are
Yeah.
asking if I wanted to sort of monitor all that's happening in each of the steps in this pipeline, yeah, I was gonna come to that. That's possible. That's totally possible.
Not the individual components inside a particular experiment, but say 5 experiments. I just want to have a quick look at them. So,
Yeah, yeah, yeah. That's possible. Managed experiment dashboard is provided by Vertex, so that's possible.
okay.
Yeah. So I'll just leave you with the Firebase thing I was mentioning so that you can take a better look. Yeah, not this one. Yeah, I found it. And in this blog post, you can actually learn how Firebase can ease your mobile deployment stuff. So that's about the I like to call it dual deployments, but you can literally call it in deployment on Vertex AI. So we are currently working on a blog post on this. So you can visit this link when the blog post is available. But the blog post basically redirects you to my GitHub repository where all of this stuff is coded. So yeah, proceeding forward. Now, can we incorporate CI/CD? Because when we are talking about DevOps, how can we miss out on CI/CD, right? Now, yeah, let's break that shackle. So scenario one, let's say I want to commit code to GitHub, and then I want to have a GitHub action workflow setup that would capture particular changes in my code, and then it would basically trigger a CI/CD build. In here, we are using cloud build, but you can use Circle CI, Travis, or whatever you prefer. Then it would basically capture a build, and that build process will basically clone my repository, compile my pipeline, create a Docker image in which the pipeline would be running on Vertex AI, and then eventually initiate a training run on Vertex AI. Now, this is totally possible, right? This is possible without, beating a sweat, without writing thousands of lines of code. And this link actually redirects you to a collab notebook that shows you how to do that from notebooks, and not from separated out models and stuff like that. So this is the first scenario. Of course, here we are treating model training as a CI/CD system. Now, what about other stuff? And yeah, just for context, here we are using cloud build, Vertex AI, Google Container Registry in order to push our custom Docker container and TensorFlow extended. So, but you should be able to replace these things with anything of your choice, as long as things are operating within Vertex AI's bounds. These things should be pretty, tightly integrated. Okay. So let's take another scenario. Let's say from Jupyter notebooks, I want to trigger a build that would basically clone a repository, create a Docker image, push the Docker image to GCR, and compile that. We are not yet submitting that compiled pipeline to Vertex AI for the final execution. And we want to be able to, of course, so upload that compiled pipeline to Google Cloud Storage buckets, right? And this, in case someone is wondering, how does the build actually look like? So this is how the build looks like. We first clone the repository, we then build the TensorFlow extended image in which your pipeline would be running. We basically then compile the pipeline and then have that compiled pipeline uploaded to a central GCS bucket, which of course we can specify. So this is, I hope you are familiar with this build logs and stuff. So I just wanted to introduce how things look like from a machine learning perspective. And then I want to sort of get that compiled pipeline from Google Cloud Storage and in a Jupyter notebook. And from that Jupyter notebook only, I want to submit it for execution to Vertex AI. Now, this is a very straightforward scenario. But what about I want to have some triggers set up in place and have that trigger, submit my pipeline for execution to Vertex AI. And these triggers could be literally anything. Let's say arrival of new data could be one trigger, arrival of new model architecture could be one trigger, arrival of new hyperparameters could be one trigger, arrival of new data pre-processing logic could be one trigger, right? And basically the idea would be to create a pub-sub topic and have a cloud function deployed, which would be basically subscribed to your pub-sub topic. And as soon as you publish a message to that pub-sub topic, the cloud function will trigger and a new training run will be submitted for execution to Vertex AI. Now inside messages you could pass anything. Like if I wanted to sort of retrain my model on new hyperparameters, I will pass the strings of hyperparameters and their values. Similarly, I can pass entire module paths in case I wanted to have a new model architecture trained, or I can pass messages like, hey, I have new data. Now you should be actually going to my central GCS bucket and train the model on this new data. Messages can be actually anything, and it's based on how we are configuring them. And yeah, we can operate effortlessly actually. And someone was mentioning about the central experimental dashboard. Now here are the experiments that I have sort of conducted. and here's a central dashboard for that. We can actually, go to any of these experiments and have their logs. So yeah, and automated logging at each step of your pipeline so that nothing is lost. You can always recover what was actually happening when that particular step was executing, and you can keep track of all the lineage of all the artifacts. And here we are seeing how the hyperparameter stuff has been used by all the models that I have trained and how they are interlinked and stuff. So yeah, so what I mean to say is you can operate effortlessly. I mean, you don't need to set up modules in order to be able to do that. You can let Vertex AI take care of all that, and you know have your team focus on what truly matters and deliver the excellent product that you are building. And yeah, like, it really comes down to streamlining your machine learning workflows with Vertex AI. So on a bird's eye view, gather data, train model, scalably deploy your model as we saw in the earlier code snippets, streamline your workflows with pipeline in order to be able to automate your entire machine learning project lifecycle, evaluate your model, monitor, detect the skew and drift, and based on that, make a decision whether to retrain your model, and then go back and repeat all the steps and have fun. That's literally about it. So I've been having a lots of fun using Vertex AI in my personal work and also for the organization that I work at. And yeah, here is some learning resources in case you want to take your learning forward. And yeah, now I'll leave it up to you folks for questions.
It is very similar to Apache Airflow.
It's
Yeah,
similar to Apache Airflow,
yeah,
but yeah,
and also
it,
we are using Apache Airflow, and for the CI/CD side, we are using Jenkins.
okay.
But only one advantage I'm looking here, we can get it everything in one single platform. The
Single
whatever,
platform.
yeah, in a
Yeah, single
single
platform.
platform.
And how you are managing the resource stuff?
The resource and everything we are managing in the Apache Airflow side. Now the pipeline we have created, we have a different DAX for the training, deployment, and all this. And whatever you are saying, we can manage, see the like, whatever any like jobs are failing, or we can see anything related. Whatever you are explaining, the similar things are also in the Apache Airflow.
Yeah, yeah. I mean,
So
are you
and also the in terms
provisioning?
of, yeah, so okay.
So what I was asking is, are you provisioning your resources directly from Apache Airflow? So how are you configuring those things? That's what I'm asking.
No. Actually, manually we are configuring in the outside in the job, like in a manual way. But when
Mhm.
we are running all the pipelines like a training, deployment, whatever, we are running through our Apache Airflow pipeline.
And your resources are on premise, or you are using cloud resources?
No, in premise, in-house infrastructure.
Yeah, in your own infrastructure. So
Yeah,
many
yeah.
companies might not have that, right? So you need to understand that. Many companies might not have a separate infrastructure for catering to their hardware requirements. So what if I wanted to use cloud TPUs in order to train my model at scale? That won't be possible with Apache Airflows until and unless I'm setting up
No,
the
no,
required
no. I'm
permission,
not
right?
saying 100%, but the
Yeah,
90%.
the functionalities
90%, yeah,
functionalities
functionally it
are
is very similar to the Apache
functionalities are
Airflow,
similar.
and
Yeah, yeah,
yeah,
definitely. But
mm,
what about the model monitoring part? So I know that model monitoring can be
the
customized,
custom
and you
side we
can
have
pretty
written
much,
down. Yeah,
yeah.
actually,
So
initially we run everything in a bash script in the Linux system. Then we moved to the Apache Airflow, and
mhm.
now again I'm seeing the Vertex AI. But Vertex AI like is a single platform. Everything we can get it in single platform, so it will be like a
Yeah,
advantage. Yeah.
so one of the other advantages, one of the major other advantages here is you are getting this stuff from the forefathers of MLOps. So Google's been doing MLOps since eternity. So these practices are already implemented by Google, and they are being operated at Google services at scale. So that's what we are getting, sort of, in a very friendly and developer friendly way. So that's what
No.
I was meaning.
Yeah. And is there any limitation for the image data?
There's no limitation. It's completely based on us.
Okay. And what about the like uh, any data like is there any possibility we can lose the data when we are executing any pipeline or anything? Or do we need to
Currently,
create in any iterations, or and
the
we
data,
not defining any like a particular flow?
see, the data availability part is 99.9%, and the data losing part that you are mentioning, if you are storing your data inside a Google Cloud storage, those are hotline storage services. I don't think they are going to disappear right off the bat. So yeah, in my experience, the data losing factor is like almost not possible based on the clients and based on the folks that I've interacted with inside Google. So
Or is there any issues related to the format of data?
yeah, you can see if you are, it again depends on the kind of framework that you are using. For TensorFlow, it's recommended that you should use TensorFlow records, but for PyTorch you may have other formats. For MXNet you may have other formats, and all of those stuff is supported. So
Okay.
yeah.
Okay, that's good.
Yeah.
Okay.
I had one question regarding the storage. So do we
Go ahead.
have to use Google Storage, or if our data lake is somewhere else, can we use that instead?
Yeah. That's a great question. So for TensorFlow, it's recommended that you use Google Cloud Storage because it has very tight integrations with that. But in
Mhm.
case your data lake is somewhere else, let's say Azure or uh, AWS S3, you should be able to make use of hybrid cloud APIs and connect your data lake. So that's possible.
In that case, do we have to pay for the storage as well? Because then we'll be
Yeah,
paying for
because
two.
you are hosting your data lake in a separate storage system, right? So that cost will not be included in your Vertex AI billings. Yeah. Yeah. Oh, so
Oh,
in case you ask that, uh, in that case, will Vertex AI charge me for storage stuff? No, it will not.
okay.
Yeah.
Good.
What are some best examples of companies which have human augmented AI flow in computer vision products? I'm not sure if I understand this question. What's meant by human augmented AI flow?
This is an anonymous question on Slido. If there is anyone who's present here who has written this question, would you want to elaborate? Okay, no problem. I think if there is any more details required on this question, feel free to reach out to us. Sir, there is one more question on Slido. I have just put it on
How
the
can
chat.
we use AIML to identify defaulter risk profile and individual? I think this is a bit out of context for this session because it's related to a different machine learning problem. In case anyone's interested, we can always schedule separate calls in order to answer these questions. But I would really appreciate it if things were related to ML ops and Vertex related stuff. Yeah, this is a bit
I
out of context, Anuj. Yeah, Shweta, you were saying something.
Yeah. So currently you're talking about one model, right? So suppose a classification model, but what if I have multiple models inside a pipeline?
Yeah, I
And
mean, it should be pretty much doable. So in our workflows, we incorporate detection, segmentation, and classification models, all three in from the same data set. Of course, levels are different, so it's doable. I mean, as long as you can ensure you have the right custom training modules in place, it should be doable. It's not like uh, these offerings are only limited to classification. So, but if you are using the AutoML stuff, then these are limited. But I'm assuming that you have your own custom model training code in place. So yeah, that if you are using those things, then yeah, you can pretty much incorporate that.
but what if my inputs for both models are different? So there's some
That's
input that I'm
possible.
feeding into
So
one model, and then the output of first model is my input for the secondary model.
yeah, that's also possible. I mean, in case you wanted to use the predictions of your first model and feed that to your second model, like key layered predictions, that's also possible. In that case, you would want to create your pipeline accordingly. So first I would have the data set as my first pipeline component, have my model trained and deployed. Let's say deployment is as per my wish, and then basically that model should be connected to the model that you are about to train, and that training component should be sort of pre-configured by you. But long story cut short, it's possible as long as the pipeline is defined in the right manner, and as long as you have defined it in the expected way, it should be doable.
Okay, thank you. And also, can we get the copy of this
Yeah, yeah.
presentation?
Anuj will have it sent to you.
Yeah.
Happy to take a few more questions before I hop off.
Can we get the free credit to use this particular platform for the testing purpose?
Yeah, it's probably up to Anuj, but if you asked if I can use GCP free credits in order to experiment with this stuff, yeah, you can.
Yeah. Okay.
Okay. Any more questions? Anyone has?
One more question. I was checking the pricing of Vertex AI, and for deployment and online prediction specifically, so say
Yeah.
it says $1.25 per hour.
Yes, that's right.
So what if I'm only using it for say 10 seconds?
Yeah, I mean, that that pricing is based on a configuration that probably might not be well suited for you. So in case you knuckle down the hardware that's underlying that particular deployment configuration, you might be able to reduce that cost. So it's important for me to first understand what kind of models that you are catering to, and on what basis and on what scale your prediction requests are going to be coming in, and how you are actually tackling those prediction requests. Should they be made in an online manner, or could they be batched? Because these things all
Batch
influence your.
prediction.
So in that case, you should be looking at the batch prediction pricing, right? You mentioned you were referring to the online prediction part.
Okay.
Yeah, but you can configure your different deployment hardwares and auto scaling capabilities. So based on your requirements and use cases, I think it makes sense to actually change the default scenarios and see what the pricing looks like. But in any case, if you feel something is off the grid, then feel free to reach out to Anuj, and probably Anuj can uh, connect with the relevant folks from the GCP team. So
Yeah.
Okay. Thank you.
I'm happy to sort of chat offline as well. My email ID is probably in the calendar invite. So in case you want to discuss things further, I think the Google Google for Startups team can always schedule a call, one-on-one call, and then we can take things forward. But yeah, um, I'm happy to sort of answer all the questions that you may have regarding Vertex AI. In case I do not know the answer, I can probably connect you with the relevant folks that can answer that.
Great, great.
Yeah.
This was very helpful, Sayal. Thanks a lot for the great session and making it very interactive. So, thanks a lot for doing this. Thank you, everyone who has joined on a Saturday morning. The link to this recording and the speaker slides will be uploaded in the one-stop hub that you have, also in the calendar invite that you have. Don't forget to share the feedback with us, and looking forward to see you in the next session.
Yeah. Bye, folks. Thanks.
Okay.
Okay,
Thank you,
thank you,
everyone.
Shaq and
Bye, guys.
Yeah.
okay.
Thanks.
Yeah.
Yeah. Bye.
Thank you. Okay.
Thank you. Bye.
Thank you, Ram and Venkat.